So first, before I take your questions, I had a student that asked a question about number 13. This is the Fall 17 Exam 1. It was on one of the quizzes today. By the way, greens in here, blues, who's green? All right, so some of y'all had the quiz today. You will have a different quiz on Monday. I've jumbled them all up. So just because I'm going over this question doesn't mean that you're going to have it. I think this was the 4M green. But it's a motorcycle. It's moving at a constant velocity. It accelerates at a rate of 4 meters per second squared to a speed of 35 meters per second in 5 seconds. And I want to know the initial speed of the motorcycle. You know, honestly, I look at this question and it's just a jumble of numbers and words. And that's probably true for you too. But what I recommend that you do is you just begin by writing down what you know. And so just start. I know that it accelerates at a rate of 4 meters per second squared. So I know that's my acceleration. What you have to be careful of with the acceleration is determining is it positive or negative, because I don't always tell you that if it's positive or negative. In fact, I don't usually give you the sign of the acceleration. But in this case, I know that that it's moving at a constant velocity, and then it starts accelerating. And so if my velocity is positive, which it is because it comes up to 35 meters per second, it's speeding up, so the acceleration is also positive. So you probably would have assumed that in this problem. The final speed is 35 meters per second. And it does that in a time of 5 seconds. And I want to know what is the initial speed of this motorcycle. First of all, if it's accelerating at 4 meters per second squared over 5 seconds, that means that it's going to accelerate a speed of 20 meters per second, right? Because 4 meters per second squared times 5 is 20 meters per second. It is speeding up by 20 meters per second. And if it ends at 35, then that means that it must have started at what? 15, right? 15 plus 20 equals 35. So I think you can sort of reason it out, but if you can't, that's fine. Let's think about the equation and what that says. Now there are two equations, x equals v naught t plus 1/2 at squared, and then also v equals v naught plus at. This one has too many unknowns. I don't know x, and I don't know v naught. So let's just look at this one. I know v, I know a, and I know t. So I can use this equation to solve for v naught. So I have v naught, the initial velocity, is v minus at. That's going to be the final velocity, which is 35 meters per second, minus 4 meters per second squared, times t, which is 5 seconds. And so that's 35 minus 20, which is 15. So that's the right answer for number 13. That was on the 4M green quiz. Could be on your quiz next week, but probably not. Like I said, I jumbled them all up and I used different questions, almost completely different questions for all of them. Okay, does that follow with that? All right, there's one other question that somebody has asked me about. I think it might be on this exam, so let me find it and then I'll address your own questions. Oh, this one, number 12, or I think there was a variation of number 12 where I have two bikes that are either moving apart or moving together, and I want to find what is their distance between the bikes after a certain amount of time. In this case, these two bikes, I'm just going to draw them as rectangles. I'll put some wheels on. They're square bikes. They're 100 meters apart. So this distance is 100 meters. And one is traveling with a speed of 4 meters per second, and one is traveling with a speed of 3 meters per second. Now, first of all, I don't give you any signs because I'm giving you the speed. Remember, that's the magnitude of the velocity. So what's really important here is that they're traveling towards one another. One of them then will be traveling with a negative velocity and one with a positive velocity, but that's not really relevant here. Let's say that this is the 4 meter per second one, and this is the 3 meter per second. To find x, x is going to equal to v times t. I think we talked about this in class today, where this equation is really just this equation where a is equal to 0. And if a is equal to 0, this whole term goes away, and I'm just left with that. And then also if a is equal to 0, v initial is equal to v at any other time. Because it's not accelerating, the velocity is not changing. So I have x equal vt, 4 times the time, which is 10 seconds. So that's equal to 40. So this guy moves 40 meters. And this guy, our lady, moves 30 meters. So what's the distance that's left between them? 30, right. So I say 100 minus 40 plus 30 equals to 30 meters. All right, so that would be the right answer. I think we had a variation of that. There was another problem that was similar where they were moving apart from one another, but you work it in much the same way. Okay? Are there particular questions that you people have today? It's okay if you don't have questions. That's fine. I'll just, yeah. On number 12 right here? Okay, no, neither one of them has any acceleration. So they're traveling with a constant speed. But one of them does have a positive or negative velocity. So that's not really relevant here because I give you the speeds, but it becomes relevant in that other question that was similar because one of them had a negative velocity, and one of them had a positive velocity. Can I go and find that question? It's an important distinction. Let's just clear this. Do I know where that one question is by chance? No luck on that, huh? Okay. I can probably find it pretty quickly. While I'm scrolling through this, you think about what are some of the questions you want to look at. See, that was fall 19. Fall 18, 16. Oh, here it is, number 13. In this one, the two bikes, one of them was traveling at minus 16. This, by the way, is fall 16 exam 1. The speed was 16 meters per second, but because it's negative, I know it's moving to the left. And the other one had a speed of 22 meters per second, but because it's positive, I know that it's to the right.
So that's just the direction it's going.
Yeah, the sign gives the direction. Yeah. Okay. Okay. Particular questions. We had, in chapter 2, we have the graphing questions, both qualitative and quantitative. We've done some of those in class for all the different groups. We also have the free fall questions. That's going to be on the quiz. I told y'all that. It's on the quiz. It's on the exam. It's really important for chapter 3. I just want to make sure that you're on that. And you'll probably have 1 or 2 questions like that. And then our kinematics questions like we did for chapter 2, like the one we just did.
I have a question for number 11. So to get the time that it takes to go up and back down, number 11.
Yeah.
So for any of the problems, can we just take the 0 off the end of the seconds and double it? Like, does that work for all of them? Like, it takes 10 seconds to go up and back down. So if it was like 60 meters per second, could we just say that it's 12?
Yeah, I guess so. I mean, if it's, you just move the decimal place over, because you're dividing by 10, right? That's really what you're doing, is that,
So that works for all of them?
I guess so. I think so. I mean, these questions that I give you will be fairly simple. They'll be a lot like this, right? So if I'm trying to find the time, I'm saying that the velocity at the top is 0. So I'd say v is equal to v0 plus at. And so it'd be 0 equals 50 minus 10t. And so the reason that works is because you're dividing by 10 to find the time to get to the top. But I caution you from finding tricks like that. I know that you're really sharp and that you're just trying to find easier ways, like faster ways to work through these. But it's really important that you understand these sort of ideas too, that the velocity at the top goes to 0.
Okay.
All right. Does that answer your question?
Yeah.
Yeah. Okay. I can scroll through. If you'll have particular questions, you'll holler out. Yeah. One what? Oh yeah. Let me. What up? 1B from the homework. Don't usually spend much time in class doing the homework. I don't really stress it that much, but it is useful for extra practice to go through those problems, and the solutions for the homework problems are online. So just work through them and you know, check your answers and your work. There is a problem in chapter 2 that I think it was number 4 that was solving a system of equations, and you're not going to have to do that for the exam. I think I've told everybody out in the class. Let me repeat it here though, that I will not give you a system of 2 equations with 2 unknowns. And that's like number 4 in the chapter 2 homework, where you have to substitute one equation into another. That is important for you to do, and I think we do it in lab, but it's too tedious, the algebra, and even a really good student will often make a mistake. I mean, I'll often make a mistake too. So, chapter 2, right? What is the car's maximum velocity? Oh, good. Yeah, so here I'm looking at a distance versus time graph. And the first part, you're supposed to find basically the average velocity for the first part, right? The velocity from here to here. That's for 1A. But then in 1B, you're looking for the car's maximum velocity. And by the way, for this, you find that the maximum velocity is 6, right? Or not, the average velocity is 6 meters per second. Am I right about that? That's what it looks like. 90 divided by 15. About 6. But here, I'm looking for the maximum velocity. And you want to find the part of the graph that has the steepest slope. And so it looks like this part of the graph has the steepest slope, and that's going to be the maximum velocity. So the slope of this part of the graph is rise over run. That's 90 minus 60 divided by 14 minus 12. This is 14 right here. And so that's 30 divided by 2, or 15 meters per second. And so the point of that is that my car has a much higher speed right here, 15 meters per second, whereas the average speed across this whole thing is really much, much smaller than that. Okay? That's good though. I like those kinds of problems where you have to look at a graph and just sort of think about what the motion is like. You'll see stuff like that on the test. Any other particulars?
Exam 1, fall of 08, number 19. Yeah.
Okay. Do you want to go ahead and do this one? This is chapter 3, but we can preview it for next week. I think it might be, you guys, you have the skills to do this problem because you got mad math skills, right? Yeah, but because really all you need to know is your SOHCAHTOA and your trig. You sure know your trig. But it'll be on the test. So let's go ahead and begin looking at vectors. And we can go back to chapters 1 and 2. This will be on the test on Friday. I'm adding up vectors. And so let's just sketch this out first of all. I'm going to draw my coordinate system. And this spelunker starts at the entrance. We'll just let that be the origin. And he moves these distances. He moves 30 meters west, Then he moves 20 meters at an angle 40 degrees north of east. Now, let me tell you, for your test, I'm probably not going to give you cardinal directions, but the way that I would draw 20 meters at 40 degrees north of east is to draw it, this is it never eat soggy waffles, right? It would look like this. And this is north of east, 20 degrees or 40 degrees north of east. Actually, if you're really tracing out the spelunker's path, you would really draw it like right here. But we'll see that when we get into vectors, that I can take a vector here, and I can translate it over to the origin. I can move a vector around in space as long as I don't change the direction or the magnitude of that vector. So I'm going to draw it from the origin, like that. Let's get rid of this one. And then the third vector is 100 meters south. So it's going to look like this. I had 30 meters to the west, and 20 meters at 40 degrees to the north of east. That was east, 20 degrees above east, or north of east. And I want to know what is the magnitude of his resultant displacement. Just FYI, I'm going to trace out this spelunker's path. Let me show you up here. It looks like this, then like this, and then like this. Those are the three vectors, but in this figure, I've oriented them all towards the origin of that coordinate system. Okay, so now I want to do the sum of all these vectors. And when I say the sum, I mean the vector sum. It doesn't just mean adding the numbers. You have to do additional things. The first step is to find the x and y components. The x component of a vector is equal to a cosine theta. And the y component of a vector is equal to a sine of theta. Let me draw a vector over here. We're going to get into this in class on Friday, or on Monday and Wednesday. But we're only going to have one day to cover this. So you need to be prepared. If you're in my Monday class, you need to finish your notes, because we need to do some serious practice on this to prepare you. Likewise for the Wednesday folks. So this is my vector A right here. You'll see that sort of? Try to see if red is better. Is that better? Okay. So there's my vector A. It has x and y components. You can think of them like shadows of the vector on the x and y axes. So the x component is going to look like this, ax. And the y component will look like this, ay. You can draw these vectors on a triangle, and they would look like this. There's my vector A. This is my vector ax. And this is my vector ay. These are the components that make up the vector A, your x, and your y components. So we need to calculate the x and y components. You can probably tell this is a right triangle. So that's my angle theta. And so that's where I get these two equations, that ax is equal to a cosine theta. That's from SOHCAHTOA, right? CAH cosine of theta is equal to adjacent, that would be ax, over hypotenuse, that would be a. And so that's where that equation comes from, to find the x component of my vector A. So what is the x component of the 30-meter vector? It's just 30, right? In fact, actually, it's negative 30 because it's in the negative x direction. What's the x component of the 100-meter vector? Sorry, it's 0. There is no x component because it's all on the y-axis. And now I can find the x and y components of this vector. And so I'll just call it vector A. Ax is equal to 20 cosine 40. Ay is equal to 20 sine of 40. Those are just for my trig functions, SOHCAHTOA. Sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. Be careful if you're in calculus. Sometimes in calculus, they'll ask you to put your calculator in radian mode. You will never use your calculator in radian mode for physics. So if they're asking you to do that, just make sure that you switch your calculator back to degree mode when you come into physics. So 20 cosine of 40 is 15, and 20 sine of 40 is 13. Those are the lengths of those component vectors. I'm going to redraw this. And when you do this on the test, you won't need to draw it this many times. This y component is 13. This x component is 15. This is 100. And this is 30. My next step is to combine x and y components. That's best done on your coordinate system. I'm going to have now two vectors. This one will be 100 minus 13, or 87. And then this vector over here, what will that vector be? The one in the negative x direction. Let me show you what I did for this one. I know we're going kind of fast. This is here. This vector is 100. This vector is 13. The 100 is in the downward direction, so I know that the final vector is going to be down. So the length of that vector is 100 minus the smaller vector. So it's going to be 87. That's the magnitude of the vector. In fact, it's in the negative direction. So what's going to be the magnitude of this vector? 15, right, because I have 30 here, 15 here. So the magnitude of this vector is going to be 15 meters. That's 30 minus 15, which I got here and here. Okay? So now I'm looking for the magnitude of the resultant displacement. If I add these two vectors back up, I get a displacement that's somewhere over here. Actually, if I were to draw it to scale, that vector would be closer to the y-axis because my y component is really big. So in order to find that magnitude, I say the square root of 15 squared plus 87 squared, and that'll be my answer. Where did I get that square root of 15 squared plus 87 squared? I want to venture a guess. Pythagorean theorem, right. Because I have a triangle here. Let me draw that triangle. I have the 87 meters, I have the 15 meters, and then the resultant vector is right here. So this vector is what I'm looking for, and it has a value of 88.3 meters. Okay? I don't think you could really pick out the answer. You really have to work through it. You're going to have to add up 2 or 3 vectors, one of which will be off axis. And we're going to work on that Monday. But, you know, if you're not just looking for stuff to do over the weekend, practice your vectors, because you're going to have, let's see, you have 28 questions. You'll probably have 4 or 5 questions that are just vectors. And some of those are going to be easy and straightforward. This will be the most difficult of them. By the way, this is one of those problems that should take you about 2 to 3 minutes on the exam. So it just takes a little bit longer. Once you do it a bunch, it's going to be easy. Right? If you've done it a lot, it'll be really easy because it's nothing really new. It's just your trig. All right? The vector stuff is a little bit new. But with practice, you will be really good at it. And you need to be, because chapter 3 and chapter 4 and a couple other chapters at the end of this year, and then next semester too, we're going to do a lot of vectors. I need to know that you can add vectors. You can, right? Yes, that's the right answer. Okay, I'm going to clear this. Thank you, Shayla. That's a good question. You will see it next Friday. It's not hard if you know how to do it. It's hard if you don't know how to do it, but if you know how to do it, it's not hard. Okay, you know how to do trig, like you knew SOHCAHTOA, and you know the Pythagorean theorem. That's really all that it is. It's just, you're right. If it's new, it's difficult and it seems overwhelming. But with practice, it will be really, really easy for you. Any of you can do it. All of you can do it. You know that, right? All of you are in this class. All of you have had the right math courses to get you in here. I know that might have been a while for some of you, but you can do it. Everybody can do it. Okay. Other chapter 1 or 2 questions? Y'all okay on these things, these qualitative questions? I love these questions. I like to ask them. You'll see several of them. Can you describe this motion? Is it positive or negative velocity? It's a positive velocity because the slope of this graph is always positive. And is it increasing or decreasing? It's decreasing. It's getting slower. Big slope right here, really steep. Small slope right here, really shallow. Number 16 is one of those free fall problems, but notice that it's different. Who asked that question? Was that you? Tell me your name again. Sophia. Sophia. This one's different, and this one, your little trick isn't going to work. So be careful about that, because here, let's just work it a little bit. It's different. So here, I'm dropping a ball. Y is equal to 12 meters. I know A is minus 10, and I want to know how long does it take to reach the bottom. So what is my time? I also know something else here that's not stated. What is that? You know? The initial velocity. You are amazing. All right, rock stars. I don't know if probably I could be wrong about this. I don't want to stereotype rock stars, but rock stars probably can't do this. Like, they've probably never done physics. Probably never had physics. You think? Maybe some rock stars. Okay, so y'all aren't rock stars. Y'all are like rocket scientists. That's better. All right, so if I want to find the time, I say y is equal to v naught t plus 1/2 at squared. You're very fortunate that v naught is equal to 0, because it is 0, this term goes away, and you don't have to use the quadratic equation. That's another promise that I'll give you. You will never have to use the quadratic equation on your exam. It's just tedious, the A's and the B's and the C's and all that. I think there is a homework question where you have to use the quadratic. I think I did it in the notes. And you need to know the quadratic just for life, I guess. But you'll do it in lab for the projectile motion next week. But I'll never ask you to use it on the exam, because half the time I get it wrong, because I just get my A's, B's, and C's all mixed up. So here I say 12 is equal to 1/2 of minus 10. That's my acceleration, times t squared. Can you see the mistake that I've made already? What is it? Huh? Right, I'm going to have the square root of a negative number. The reason is that really, this is my initial position of 0, and this is my final position of minus 12. And so really, I need a negative right here. And so t is going to be the square root of 12 divided by 5. The negatives cancel out now. And what's that? The square root of 2-ish? I think it's 1.6. Yeah, 1.6. I have 1.55. Yeah, it really should be 1.5, but we'll go with 1.6. Maybe I use 9.8 on this test. I don't know. Anyway, that's what I have is 1.55 or 1.6. Okay? I want you to use negative 10. Yeah, I try to make it so that you don't have to use a calculator hardly at all. Maybe 1 or 2 questions, like the vector question, you have to use a calculator. Although, like on the MCAT, like you have to know your trig functions and know what their values are for common trig functions. And we'll get some of that this semester. You'll begin to get a feel for our right triangle. So, did I answer your question? What was your question? Yeah, use 10. Yeah. Okay. So be careful with your tricks, Sophia. I can get you in trouble. All right. Ooh, you want to do number 15? Is that okay? I like this one because there's just more to it than you really see. Again, I look at it, jumble of words and numbers. That's all that I see. But as you begin to go through it slowly and write down things, it will begin to make sense. I look at this and immediately I don't really know how to solve it. But I begin just by writing down things. And that's probably true for you too. If it's true for me, it's probably true for you. So a car initially travels at 10 meters per second. That's my V naught. I'm certain of that. The driver sees a traffic light and steps on the brake so that he slows down at a rate of 2 meters per second squared. I can look at the units right here and tell that's my acceleration. Knowing your units will really help you. So my acceleration is 2 meters per second squared. But if I'm assuming that this is positive, which I think it's safe to assume that, and he's slowing down, that means my acceleration has to be opposite. So it's going to be negative 2 meters per second squared. It requires 5 seconds. That's t. What distance does he cover? So that's x. I want to know x. And now that I've written all this down, now this doesn't seem like a difficult problem at all, because x is just equal to v naught t plus 1/2 a t squared. And so that's going to be 10 times 5 plus 1/2 of negative 2 times 5 squared. That's 50 minus 25, which is 25. So the answer is 30. But notice here that if you had gotten this sign wrong, if instead you had positive 2, which some of you will do, and students always do that. Not always, but often that's a common mistake. Then they would have had a positive here, and then instead of having that, they'd have 75. So they would have put the answer of 80, but that's not correct. So if you get the sign wrong, that's really what I was testing, is can you get the sign for the acceleration correct on this problem? And if you do, then you'll pick 30. If you don't, you'll pick 80, and that would be wrong. Okay? It's a good wrong answer because it shows that you sort of know what's going on, but you have to be careful about the sign of the acceleration. Often on these problems, there are unstated facts that you know. That's true in the free fall too, like with the velocity at the top is 0 and the acceleration is minus 10. Often that's the case, that there's unstated, assumed things in that problem. And you need to be aware of that. You need to be looking out for those things. You'll get it. Yeah. Tell me your name again. Tell me your name again. Logan, right. No, do you? No. I know, Logan. I know. And I've had many, many students do that. And they all tell me that the thing that helps them is to practice. So that when you walk into the test, that you don't really need to think about it. That's really where you want to be on Friday, that you know it so well that you don't even need to think about it. But if you come to a question like this, I think just beginning at the beginning and just starting to write down things will help to ease those anxieties. You're not alone. It's almost everybody in this. I would venture that it is everybody in this. Who likes exams besides me? I like exams. I mean, I like giving them. But who likes taking them? Anybody? Anybody? No. You're not alone. Everybody else is the same way. But you can do well on it. It's practice. That's what's going to help you. That's true on almost every exam. Okay? All right. Let me do one more. All right. This was a good exam. I like it. Y'all know how to do this? Instantaneous acceleration? What would you do at point C? Find the slope. Can you tell me what the answer is, sort of right off, without really writing anything down? You're amazing. Yes, it's -2. I know that it has to be negative at point C because this line is negative. So that gets rid of almost every option. Oh, not B. And then I can find my slope here, 4 minus 2, 4 minus 3, 2 divided by 1. 4 minus 2 divided by 4 minus 3. Rise over run. And so that's going to be my slope, which is -2. Really, my rise over run would be -2 over 1. Okay? Anything else today? We'll probably have another help session on Thursday. Move our Friday help session to Thursday. That way, if there are burning questions before the exam, I'll be available to help you. All right? Now, let me stop this. Don't leave the room.